So today is the last lesson of chapter 7, and it has to do with Pythagorean theorem, which is why we split lesson 6 up into A and B. So today is part B, and we are talking about midpoint and distance. Now here's the good news. There is no new vocabulary. Yeah. But we need to talk about midpoint. What does a midpoint mean? Turn to your neighbor, tell them in your own words the definition of midpoint. Okay, so the midpoint is the middle. What else do we know about the midpoint, Jason?
It makes each side congruent.
Correct. So it makes each side of the segment that it's the midpoint of congruent. So now I'm going to be giving you problems where I maybe give you the endpoints, and I want you to find the exact coordinate of the midpoint. So now I'm not just telling you that it's the midpoint, we're going to actually find the coordinates of it. So Tyrese says, wouldn't you just take the total distance of the segment and divide it by 2? There you go. So there's two ways that we're going to find the midpoint. The first is on a number line, which is what we've been doing so far. Okay? So on a number line, to find the midpoint, remember capital M typically in math means midpoint. We take the coordinate of point A plus the coordinate of point B, which gives you the whole length, correct? And then what do we do to get the exact middle? Divide by 2, okay? So if I give you the coordinates on a number line, you should be able to find the midpoint very easily. Okay, so then what if my segment lies on the coordinate plane, meaning that it is on the XY axis? My midpoint is not just going to be one single number now. It's going to have a coordinate. So it's going to have an X, comma, Y. Now the question is, how do I find that X, comma, Y? In order to find my midpoint on this kind of more diagonal segment, that has an X coordinate and a Y coordinate. Nod that you understand. Yes? Yes. We understand that? Okay, so we need to find, and let's see if this makes sense, if we find the midpoint of the X coordinates, so I'm going to draw the X coordinate here and this X coordinate here. If I can find the midpoint of those X coordinates, do you guys agree that that would give me the X? So I'm looking at just my X's right now. If I can find the midpoint of those, would that give me my X coordinate? Yeah. And so then how would I find the midpoint of the Y's?
Find the midpoint of the
or find the Y coordinate, you would find the midpoint of the Y's, yes?
Basically, it's like doing the same exact thing as the top, except you're doing it like in a way.
Exactly. So Delilah says basically we're doing the exact same thing we did on the number line, but we have to do it on the X number line and on the Y number line. Make sense? So we're just doing this twice. Now there is a formula for this to make it easier for us so we don't have to draw the picture every single time. Okay? Basically, what did we do on the number line? A plus B, and then divided it by? 2. So to find the midpoint of the x's, what do you think we're going to do?
We're going to do the same thing, except we have to do the x coordinates and the y.
Exactly. We're going to take the x coordinate of A and add it to the x coordinate of B, and then divide it by 2. Now, there is a notation for this, and we've actually seen this notation before. Do I know what number is the first x coordinate? No, so we call it x sub 1.
That's cool. I like that.
Because this is the x coordinate of the first point. What do you think we will call the x coordinate of the second point? X sub 2. Because this is the midpoint. No, we don't give the midpoint its own little notation. We call it big M. That's why we put that big M there. Okay, so the x coordinate is going to be x sub 1 plus x sub 2, and then you're going to divide by 2, comma. I know. Exact same thing with y. So we have y sub 1 and y sub 2. So we do y sub 1 plus y sub 2 and divide it by 2. Do we do anything with these after that? No. Your answer will come out as a coordinate. So an x, comma, y. Okay? That would be your answer. That's your midpoint formula. Okay? So let's do a couple of examples using the midpoint formula. And then we're going to derive, mathematically, the distance formula. So here's your first example. Segment AB has endpoints at -4 and 9. What is the coordinate of the midpoint? And then I drew a number line. Okay, so here's what I have so far. I, on my number line, put the endpoints -4 and 9. Now, on my number line, I counted by 2s, so 9 is exactly halfway between 8 and 10, okay? And there's my segment. Let's do this algebraically first, and then we'll plot that midpoint on the number line, and just double check to make sure that it makes sense, okay? So, looking back at your formula for the number line, we take the coordinate of A plus the coordinate of B, and then we divide it by 2. So what are we going to do?
-4 plus 9.
-4 plus 9. And then we're going to divide it all by 2. Okay. Ladies and gentlemen, what's -4 plus 9? 5. Divided by 2.
My bad. I got 6.
Yeah, double check that. Okay, guys, now 5 divided by 2 doesn't help me much when I'm trying to put that on the number line. 2 goes into 5 how many times? 2 times, and then we get 1/2 left, so 2.5. So our midpoint should be, this is halfway between is actually 3, so we go 1/4 of the way between, and we label that M. Does that look like 2 congruent segments?
Yeah.
Yeah. They are.
Just you blind.
Okay.
Well, if I'm drawing
So example 2, this time I tell you that our segment actually lies on the XY axis because there's an X coordinate and a Y coordinate. Point E has coordinate 7, 5, and point F has coordinate 2, -4. No, you do not have to graph this on the coordinate plane. We're just going to use the midpoint formula. I'll do the X coordinate with you guys, and then I'll have you guys do the Y coordinate together, okay? So using our midpoint formula, I know that M, and this is, I do want you to show your work this way. I'm going to move it up for just a second. It's x1 plus x2 divided by 2. Okay, what is x1?
7 and 2.
7 plus x2, that means the x coordinate of the second point, which is 2. And then we're going to divide it all by 2, comma. Fill in the y coordinates for me.
Oh, I got you.
Kyrie, what'd you get?
5 plus -4.
5 plus
Or just 5 minus
-4.
5 minus
Or 5 minus 4.
4.
Okay, let's simplify. Ladies and gentlemen, what is 7 plus 2? 9. So this is going to be 9 over 2. Can you leave it like this?
No.
Yes.
Oh, wait, what?
It's okay. Because fractions are our friends, and since I'm not making you graph it, it's actually preferred to leave it this way. Okay?
If you put in decimal, it would be 4.5, right?
If you put it in decimal, it would be
4.5.
4.5. Yes.
And-
I like it 9 over 2. Okay? Unless you are graphing it, like I give you a coordinate plane and I want you to graph it, leave it as a
Are
fraction.
you going to do that for us?
No.
Oh, okay. I'll leave it.
At least not today. Okay. 5 plus -4 is the same as 5 minus 4, which gives us what? 1 over 2. And then those are our coordinates. So if we were to graph the 2 endpoints, this point right here would be exactly in between those 2 endpoints. That's what this is saying. All right, ladies and gentlemen. So now we're going to do the distance formula. I want to know the distance between points A and B. We can do one thing. We can label the coordinates of A as x1, y1. Is everybody comfortable with that?
Yes.
Okay. What could we name the coordinates of B?
X2, Y2.
x2, y2. So let's do that. And then let's talk about what we notice here. Now, I told you guys that distance has to do with Pythagorean theorem, which is what we did on Friday. Does anybody have an idea, and I'll give you a second to talk about it with your neighbor, as to how we can tie finding the distance of this diagonal line to the Pythagorean theorem? Let's make a triangle. Watch. How did you guys see the triangle? Did you see it going this way, or did you see it going this way?
That's the hypotenuse.
Okay, I like it this way, so let's do this. Is that a right triangle?
Maybe.
Yes, it is. We can assume it's a right triangle because we are going straight to the right and then straight up. So it's perpendicular lines. We know that.
But it didn't have the square thing before you wrote it in.
I wrote in the square thing because I know that those two lines are perpendicular, for sure. Okay, so then my question is, how can we find the length of both of the legs? We did this on Wednesday.
A squared plus B squared equals C
Well, we know it's A squared plus B squared equals C squared. We're going to get to that.
squared.
So, okay, so let's write it in. A, B, and then this comes out to C. Okay.
First you gotta find out what A and B is.
So we know, let's write out the Pythagorean theorem, that A squared plus B squared equals C squared. Okay, so we know that. Tori, I kind of heard you saying it. How can we find out the length of A? x2 minus x1. Does everybody agree with that? If I take this point and subtract it from this point, does that give me the length of A?
Oh yeah,
Yeah, okay. So let's plug it in. So that's going to be A. So in parentheses, let's plug in x2 minus x1, and then we're going to square it, right?
Plus,
Tyree, how can I find the distance between the x1, thank you.
white out.
I'll white it out later.
Okay.
Okay. What about the y's? How can we find the distance of B?
Y sub 2 plus,
y2 minus y1.
Yeah.
Squared. Okay, so y2 minus y1 squared. Okay, don't write anything else just yet. Now I want to create a formula that I can just plug everything in and then simplify as much as I can, and then that gives me the answer. So I don't want C to be squared over here. How can I get it so that it's just equal to, we actually call it, when we're looking for distance, we call it D. So is everybody okay if I change it to D
Yes.
for distance? How can I make it so that instead of D squared, or it's Pythagorean theorem, it's C squared? What did we do to get the C by itself? Square root the whole other side, right? Like here I would do this because then the square root and the square cancel, and then we have to do it to that. So is everybody okay with taking the square root of that whole thing?
Yes.
And that's going to give me the distance?
Yes.
Okay, there's your distance formula. Box it. You guys just derived the distance formula mathematically all on your own. Give yourself a round of applause. Okay? All right, so how are we going to use this formula? On mine, I ran out of room, so I'm going to do the next example on the left page. If you still have room, about 4 lines should do it. Okay? 3 to 4 lines.
Yes.
Okay. So example 3, like I said, if you have room on the right, put it on the right. If you don't, put it on the left. It's okay because you will have enough room for all your left-hand questions. So the question is, what is the distance between U, which is at -7.5, and V, which is at 4, -3?
I get it.
We're just going to plug everything into the formula. Here's how I want you to show your work. D equals. Now, ladies and gentlemen, let's think about this. Does it matter which coordinate I put first
No.
for x1, y1, and x2, y2?
No.
It does not. Now, what does matter is that they match. Okay? So I always just pick the first one to be x1, y1. So let's label this x1, y1, and v is going to be x2, y2. Why does it not matter?
Because you're adding. It's addition.
No. Let's think about this.
Addition.
No, we're subtracting, actually. But then what do we do to it?
Addition.
We square it.
Come on.
What happens when you square something? It becomes positive anyway. Okay? Now, it does matter that these two match. We're going to square them, but then after we're going to square root the whole thing. Okay?
So we're going to square everything.
Order of operations says that we have to do everything inside first. So we have to do everything inside the radical first, which includes adding those two together, and then we square what we get. Okay?
How can we call it a square root radical? We can't just call it square root.
because sometimes you are taking more than just a number times itself, which we get to later. Okay, so D equals, x2 minus x1. So let's do 4 minus -7, and then we square it.
Hey, that's 2 negatives, that means positive, yeah.
It will be. But right now I'm just plugging in everything that I know. I'm not changing the signs of anything yet. y2 minus y1. So we have to use this -3 because we used the 4 first. So -3 minus 5, and then we square it. And then what do we do to the whole thing? Square root it. Now, we have to evaluate the inside before we can take the square root. That's our very last step.
So we have to actually.
Sometimes it does take some work. So big square root again. Guys, what happens when I'm subtracting a negative?
Come on,
Positive.
So 4 plus 7 gives me 11 squared
So that made 2 wrong, so you make it right.
plus -3 minus 5. What does that give you? -8. Put it in parentheses and square it. Why do we keep it in parentheses?
So we can like not mess up.
So we're not going to mess up because it's going to come out positive. Okay, next step. D equals big square root. 11 squared? 121 plus -8 times -8. 64. Almost there. D equals.
Big square root.
Actually, it's just a regular square root now because we're only going to have one number in there. 121 plus 164 is 185. Okay. Or
I got
plus
you,
64.
I got you.
So you're going to take the square root of 185. Now, this is why, guys, this is why I told you that decimals are okay, but I just wanted you to practice the radical notation. Because in distance, don't we want decimals?
Yes.
Yeah. Now, your instructions are going to say round to the nearest tenth, which is 1 decimal place. So, Tyree,
Yes.
what did you get with the square root of 185?
13.6.
13.6?
I got it.
Agree?
Yes.
Did he round correctly?
Yeah.
Okay, there's your distance.
Why did I have to take my thunder? She said Tyree.
Okay?
No.
Thumbs up, thumbs down, thumbs in the middle. How you guys feel? So thumbs up is like, Mrs. Dodson, I got this. I'm ready to practice on my own. Thumbs in the middle is when we practice on our own, can you come help me? And thumbs down is like, we need to do a million more problems. Okay, so if you're 3/4, that's great. Okay? So here's your left-hand pages. Now, if you did the example, just write this right underneath, because it's not going to take as much space as I left. I just spaced it all out.
Do we have to write down or just
No, just abbreviate what you can. So number 1 says, what is the midpoint of segment RS if it has endpoints R, 5, -10, and S, 3, 6? So that's on the coordinate plane. We just did one like that.
I got you.
Number 2, find the distance between the pair of points, round to the nearest tenth. X is at -3, -4. Y is at 5, 5. We just did that. Here's a challenge for you.
Uh-oh.
The midpoint of segment AB has a coordinate 4, and endpoint A has the coordinate -3. What is the coordinate of endpoint B? So this time, I give you an endpoint, and I give you the midpoint, and I want you to find the other endpoint. Do you think drawing a picture might help you?
Yeah.
Yes.
Maybe.
Do I want you to show your work algebraically?
Yes.
Yes, for sure. Okay, but if you get stuck, you can draw a picture to help you. Okay?